The technological singularity is coming, and it won't just change a few things. It will transform life forever. From AI that can outthink any human to robots that can replace nearly every job, this shift is already underway. In this video, we're breaking down 9 specific ways the singularity could reshape everything. From curing diseases to merging humans with machines, let's get into the facts and see what's actually coming next. Superhuman AI will redefine intelligence. AI already matches or exceeds human performance in many narrow tasks: language translation, image generation, medical imaging, even code writing. But the singularity refers to something fundamentally different. A moment when AI can improve itself autonomously, rapidly advancing beyond human-level general intelligence. In 2023, OpenAI's GPT-4 was released, passing the bar exam in the top 10%, generating working code from natural language prompts and solving logic puzzles once thought uniquely human. Google DeepMind's Gemini, launched in late 2023, combined language capabilities with planning and tool use. Anthropic's Claude 2 also outperformed benchmarks on tasks like the GRE and coding challenges. These are still early iterations. The major shift will come when systems become general, able to learn, adapt, and reason across domains. That's when innovation could accelerate rapidly as AI begins to redesign itself. Stanford's 2024 AI Index report highlights this trend. Between 2018 and 2023, models improved on 50-plus benchmarks by up to 90%, while training costs dropped over 60% and time to reach state-of-the-art performance was cut in half. If this pace continues, the jump to super-intelligent systems may come sooner than expected. Everything will be automated. With each leap in AI capabilities, more of human labor becomes automatable. We've already seen this in logistics, finance, and customer support. But automation isn't stopping there. A report by Goldman Sachs in 2023 estimated that up to 300 million jobs worldwide could be impacted by AI automation, especially in sectors like legal work, administrative tasks, and healthcare diagnostics. McKinsey's June 2023 report found that 60 to 70% of current business activities could be automated with existing technology. This doesn't mean immediate job loss across the board, but it does indicate a fundamental shift in the structure of labor. In 2024, Amazon reported that it had deployed over 750,000 robots in its warehouses, handling everything from item sorting to real-time tracking. OpenAI's Codex has been used to assist in writing code, reducing development time for software teams by more than 30%. Meanwhile, financial firms are already using AI to conduct real-time fraud detection, credit risk analysis, and even generate investment strategies. When AI systems reach a point where they can adapt to new situations as well as humans do, every task that requires problem-solving, or analysis may become automatable. That includes roles once considered untouchable by machines like therapy, education, or scientific research. Human-like robots will be human-like robots everywhere. The merging of advanced AI with robotics is already in motion, and the results are beginning to show. In late 2023, Tesla revealed an update on its humanoid robot, Optimus, which can now walk, sort objects, and manipulate delicate tools using AI-based control systems. Videos showed the robot performing yoga poses, folding clothes, and operating machinery without being manually programmed for each task. In Japan and South Korea, humanoid robots are already being tested in restaurants, nursing homes, and customer service centers. Samsung has developed Bali, a small AI companion that uses vision and context awareness to assist with daily tasks around the house. Agility Robotics' Digit robot designed for warehouses has been deployed by Amazon and FedEx to autonomously move packages. What's changing now is not just the form, but the intelligence inside. As AI models grow in capability and shrink in size, they're becoming easier to embed into physical robots. That means more robots, not just in factories, but in homes, offices, hospitals, and public spaces. According to the International Federation of Robotics, the number of service robots sold worldwide rose 48% in 2023 alone, driven by demand in healthcare, cleaning, and logistics. And with edge AI chips becoming more powerful and energy efficient, these robots won't need cloud computing to function. They'll operate locally, learn from experience, and adapt on the fly. Quantum computing will reshape what's quantum computing possible. While classical computers process one calculation at a time, quantum computers operate in probabilities, solving multiple outcomes at once. That makes them ideal for optimization, simulation, and encryption-breaking tasks that are computationally impossible for current machines. In 2023, IBM unveiled Condor, a 1,121-qubit quantum processor, marking a milestone in scalability. Google announced progress toward quantum error correction, a major hurdle for real-world application. And in early 2024, Chinese researchers claimed they had used a quantum system to simulate molecular structures 20 times faster than the world's top supercomputer. Another critical area is cryptography. Quantum computers could eventually crack all modern encryption, forcing a global transition to post-quantum cryptography. In fact, in 2022, the U.S. National Institute of Standards and Technology, NIST, began standardizing quantum-resistant algorithms to prepare for this future. That process is ongoing into 2025. The implications are broad. Everything from secure communications to climate modeling and material science could be transformed once quantum systems hit scale. We're not fully there yet, but every year is getting us closer. Disease will be eradicated with AI-driven medicine. One of the most transformative effects of the Singularity could be on healthcare. As AI merges with biotechnology, diagnostics and treatment may no longer rely solely on doctors or lengthy clinical trials. AI systems are already detecting diseases early, personalizing treatment plans using genetic data, and generating new drug candidates at speeds previously unattainable. By 2023, Ensilico Medicine announced the first AI-designed drug to reach phase 2 trials. What typically takes years was completed in under 6 months. DeepMind and Recursion are also using machine learning to accelerate drug discovery and protein modeling across hundreds of conditions. Diagnostic tools are improving too. Google Health's breast cancer AI has matched or surpassed human radiologists. And in 2024, a UK study found AI-assisted colonoscopy increased polyp detection by 30%. Meanwhile, CRISPR continues to advance. In late 2023, the UK approved the first CRISPR-based therapy for sickle cell disease, and trials for Huntington's and other genetic disorders are underway. And while aging remains an open scientific question, companies like Altos Labs and Calico are using AI to explore cellular reprogramming, aiming to reverse signs of aging by retraining cells to behave as if they're younger. We'll merge with machines. As AI grows brain-computer interfaces more capable, the question arises, how will humans keep up? One answer may lie in brain-computer interfaces, or BCIs, technologies that allow direct communication between the human brain and machines. Neuralink, founded by Elon Musk, made headlines in early 2024 when it implanted a chip in a human patient that allowed them to control a cursor on a screen using only their thoughts. The US FDA approved Neuralink's first human trials in May 2023. And while still early, the company aims to restore function for people with paralysis and eventually expand human cognition. But Neuralink isn't alone. Synchron, another BCI company, has already implanted its Stenrode device in multiple patients without open brain surgery. The device records motor signals and translates them into commands, enabling users to text, email, or browse the web using their thoughts. Long-term BCIs could allow memory storage, mental communication, or skill acquisition directly from machine learning systems. DARPA has already funded projects that let pilots control aircraft simulators with their minds. Researchers in Switzerland have enabled stroke victims to walk again using a BCI-controlled spinal implant. As these interfaces improve, they may create a form of human-AI symbiosis, where our minds operate with AI as an extension, boosting memory, focus, creativity, and problem-solving capacity. Digital immortality. Digital immortality may be achievable. Another outcome that has moved from fiction to research is the idea of digital immortality. The possibility of preserving a person's consciousness, memories, or personality in a digital format. Right now, we're far from being able to upload a mind, but early experiments are underway. In 2023, MIT researchers created digital twins of human heart cells using neural networks, enabling personalized simulations of medical treatments. Similarly, the EU's Human Brain Project has been working for over a decade to simulate the human brain in its entirety using supercomputers. Projects like Replica and Storyfile allow people to train AI models on their speech patterns, behavior, and memories, creating interactive digital replicas. While these are rudimentary now, advancements in memory modeling and long-context AI like Claude and Gemini 1.5 are pushing the boundaries. The key challenge isn't just technical, it's philosophical. Even if we could replicate the neural structure of the brain, would that be you? These questions are being debated by neuroscientists and ethicists alike. For now, digital immortality remains speculative, but it's one of the most widely discussed outcomes of a post-Singularity world. Exponential innovation will replace slow progress. One of the most significant shifts after the singularity could be in the speed of innovation. Historically, technological breakthroughs have followed a linear path, small steps over long periods. But with AI capable of recursive self-improvement, innovation could become exponential. This isn't just a theory. It's already happening in early stages. Between 2018 and 2023, the time between major AI breakthroughs shrank dramatically. GPT-2 to GPT-4 took less than 4 years. AlphaFold DeepMind's protein structure predictor solved a 50-year-old biology challenge in just 18 months. AI can now design chips, generate blueprints, write research papers, and optimize supply chains. In 2024, NVIDIA announced AI-designed semiconductors that were 20% more efficient than human-designed ones. Tesla's Dojo supercomputer, purpose-built for AI, is capable of training complex models at speeds that were impossible even 2 years ago. As AI systems begin designing better versions of themselves, hardware, software, algorithms, and training data included, we could see progress in energy transportation, biotech, and material science that leapfrogs entire decades of R&D. There's a real risk of losing control. While the benefits are vast, the singularity also raises serious concerns. The most widely discussed is control. What happens when we build machines we don't fully understand? Leading researchers like Geoffrey Hinton, one of the godfathers of AI, stepped down from Google in 2023 to warn about the risks of uncontrolled AI development. In May 2023, hundreds of experts including Sam Altman, OpenAI, Demis Hassabis, DeepMind, and others signed a statement comparing the risk of advanced AI to nuclear war or pandemics. The concern isn't that AI will turn evil, but that it might pursue goals misaligned with human interests. An AI designed to maximize paperclip production, for example, could consume all global resources to achieve that goal if not properly constrained. A thought experiment originally proposed by philosopher Nick Bostrom. In response, governments are starting to act. The European Union passed the AI Act in 2023, establishing risk-based regulations on AI systems. The US launched its AI Safety Institute under NIST to create standards for trustworthy AI. China is also drafting rules that require all AI outputs to align with state values, but technical alignment is still an open problem. No consensus exists on how to build systems that understand and follow human intent with absolute reliability. And as AI grows more autonomous, the gap between human understanding and machine behavior could widen. If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.